No, put it back. You don't need it. We don't need them anymore. Semicircle. Let's put it on the x-axis, like so. That's the middle. Let's reflect it and revolve it around the x-axis. So I'm going to go behind the paper and then have it come out the paper and put it at the exact same spot. What shape is this making?
What shape is this?
So I'm starting with semicircle. So start semi circle. I draw another one around the axis I'm going around, and it goes behind the paper and it's coming back out the paper. Yeah, so it should be a sphere. Like so. Sylvia, look at, I'm a rectangle.
Ooh.
That's my negatives. This is my rectangle, right? This is, don't look at what's written. Okay? No, yeah. So I'm going to reflect it over whatever axis this is, right? So I'm going to go outside the paper. I'm going to go around and then go inside the paper. So I go all the way around and I'm making a shape with all these papers. I'm connecting all of these papers.
So like a pie?
Yeah. So now if I look at it, it's a gigantic circle. Does that help? Okay.
So
I'm stretching it across. I wish I had a better example of this.
You're just making.
I've now made a cylinder. See?
So wheel.
I know. This isn't. Kind of.
Cheese.
Yeah. It just has the fat one, so it's a cylinder.
What you said?
What is that reference?
You said cheese, now you said pie.
Yeah.
You're
I wish I had a better thing to demonstrate this. Let's look online.
Cheese is a
You're
triangle.
stretching it out.
Learner? Okay, so sorry if you're saying cheese, it's freaking pie. You said pie is a circle, but cheese is like triangle. No, cheese is circles. We love cheese. Have you ever seen that?
Okay, Riley, look at this.
This I was like
Riley,
this.
You're starting with the 2D shape. You're evolving.
and if you were to like make it come out, what
Oh, then it
shape
would
is
like
that going to?
the
Yeah.
cylinder. Oh, okay, okay.
This is not the right thing.
So you have a semicircle, right? And if you were to make the semicircle come out, what shape would that make?
These are getting ugly. This is calc.
Okay, so you have a semicircle, and you were filling it inside. What shape?
These are all very ugly.
And it's coming out. What? And you get the other half. What?
Okay, look at this shape for a second. This is a triangle. Sevia, look up. This is a triangle. If I evolve it around this axis right here, this is going inside, it's going to come outside and come all the way around. What shape is it going to make?
A cone.
Yeah, it's going to look like, watch this, Sevia. This, if I rotate it back behind the paper, out and up front, so I'm making a giant circle with that point, it's going to look like that afterwards. So I start with this. I'm going to spin it behind the paper and coming out the paper, so I'm making a 3D shape now. Yeah, and it's going to become a cone, like so.
I thought this. Oh no, it's awesome.
Questions? Making a 3D version of that shape. Yeah, but like a rectangle turns into a cylinder because we're spinning it in a circle. So the top of it is a circle, the bottom of it is a circle. Yeah? Questions about evolving? I wish I had a better simulation. Go. Mm-hmm. If I go like this and I go around, I don't go like in a straight line, right? I'm making a circle. So watch this, ready? Boom. I just made a semicircle. Yep, so I'm going all the way around. What? Going around there. So I just made a full circle. Up, going down, and around, and over. So I just made a circle shape.
And you still have like the inside of the circle, so it's creating that sphere, that whole thing.
Yes. Okay, that is the end of 1.1. That's all we had to do from yesterday. Revolution. revolving around a certain axis to make a 3D shape. These are half of a cross section of your shape. And it's making the base. Homework for chapter. Yep, that was it for that one. That's your homework. No. That was from yesterday and the end of today. What? No. I didn't give it to you yesterday because you guys all opted for it today.
Oh,
yeah. 11.1. I'm writing the other one. Oh my god, why won't it write? 11.1, page 473. 12, 13, 16. These are all cross sections. Every single problem is cross sections, except for the last one. Then you're revolving. Okay, write it down. No. I'm just telling you what it is. And then we're gonna move on. Yeah. Cool. Good. Dean, you got it? Okay, it's on the backboard too. It's right behind you. It can probably be easier to see it's right behind you. Okay. 11.2. Volumes of prisms and cylinders. Chelsea, give me a prism. Someone go take a picture of that. Yeah. Yeah, that was funny.
Can we go watch the play?
We'll play.
I'll be back, Miss Sweet.
Okay, go. You got 1 minute until points get off.
He's just gonna go out there and
Every second is a point. -4.
Oh no.
every extra second.
Okay, Chelsea, give me a prism. So a rectangular prism. Yeah. Okay, that one's hard. Can we start with a square prism? Let's do a square prism because that's easier to demonstrate. Okay, make a square. Extend it out. Yes. Did you get a picture?
Yeah.
That was so fast, Kate. Boom.
Oh no, that was.
Okay. Square prism. Okay, I want you all to imagine that you're gonna tilt it, the top. You're gonna tilt it a little tiny bit. You're gonna make the whole thing, and you're gonna tilt it. Tilt. Yes. Tilt. We have it. We're going to tilt it slightly. Hold it up. What height is it right now?
3.5 inches.
Okay, 3.5 inches. If I tilt this, if I take all these and I tilt it, and not make them fall at the same time, what's the height of it?
3.5 inches.
So the same?
Yeah.
Yep, it should be the same, no matter if I tilt it or not. If I tilt it, no matter how long, it's still the same for them, still the same height. Okay, cylinders. W. You do cylinders. What is the height of this very, very fat cylinder? Okay, if I tilt all these, is it the same? Yep. So if I tilt them, it doesn't matter. The height is still the same of our 3D shape. If our height is still the same, will it ever change the volume? No, it doesn't matter. So if I have the same shape, this is a square prism, right? Okay, if I tilt it, the square becomes a what shape? A rhombus. So it should look like this. I'm tilting it to the side. tilting, tilting. I hope I sketch this better than I did in third. Do you really want to? No. It doesn't look much better. If it's tilted, it's really fine. What is the word for a tilted prism? Anyone know?
Wrong.
Starts with an O.
Obtuse.
If I was talking about a triangle, I'm talking about a big angle, that would be obtuse. Obla.
Obligation.
Oblique prism. Yep. You got it. I got it. Oblique prisms. If I'm tilted over a little bit, it's oblique prism. They have the same height. I'm just tilting it over. So the height of this one is h here. The height of this one, if I go down like so, this is my height. The heights are the same. They have the same height, so they have the same volume. Okay, let's draw a cylinder. So these are all of our washers we had before. And then take the top of it and move it over slightly. Yeah. Yes. Yep, they have the same volume. Not changing anything about it, I'm just making it a little crooked. So pretend there's like little tiny cuts in all of these. So we have a whole bunch of washers stacked up together. I can tilt them slightly over. So it looks like this. My height is still the same. And this was my height. Same height. Same volume. Okay. So we're starting with volume. That's mostly what we're talking about for the next 2 days. This all comes from a principle that I have not used since the class, but they like to talk about it a lot in this book. Vocabulary's principle. This says that if we have two 3D shapes of the same height, and their cross sections have the same area, then the volumes are equal. This helps us when we have two shapes that are not a cylinder, or we are not the same prisms. If I took these same shapes, and I took the cross sections, would they have different cross sections? Yeah. If I took the cross section of a cylinder, what would it be? If it's parallel to the base. What do you think, Cordelia? This is the base of a cylinder. If I took a cross section that is perpendicular to the base, what would it be? So what's the base shape? What's the base shape? A circle. So if I took a cross section that is parallel to the base, what would that cross section look like? So if I cut a cylinder, if I took this and I cut it in half, and then I looked at it, what would the shape be? Yeah, a circle. And if I cut this one, it would be a square because this is the base. It would be a square. If both of those have the same area, then the volumes are going to be the same. So let's sketch. Chelsea, now let's do your triangular prism. Yeah. Triangular prism. Sketch. Triangular prism. Like so. And let's take a cylinder. Right now, their heights are the same. So heights are the same. Look, what is the cross section parallel to the base of this image? Yeah. What shape? Which one's the base? The rectangles or the triangles? Triangles. Yep. That's okay. So if I cut the shape parallel to the base, what shape would I get? I have a rectangular prism. I'm going to cut it this way. So I'm cutting it in half. Yeah, you have a triangle. So I have a triangle right there. Ronaldo, how do I find the area of a triangle? Close.
1/2 is.
Yep, 1/2 base times height. What's the cross section, Rodelli, again, of a cylinder? Of a circle. Which is, what's the area of a circle? Formula. What? We just did circles. We know this.
Pi r squared. Pi squared. Pi r squared.
Pi r squared. Yep. Pi r squared. Boom. If these two areas are the same, then the volumes are going to automatically be the same. That's what this principle is saying. So if areas of base the same.
Does it say pires?
Yep, pi r squared. Then the volumes are equal. So you need to figure out what the area is first. If those are the same, then the volumes are going to be the same because they're both the same height. Cool. I don't want us to dwell too much on this principle because you can calculate that same thing each and every time too. It's just a shortcut. So volumes of prisms and cylinders. Let's do cylinders over here. Okay, we started off with a square prism. Then we went to rectangular. There are so many different types of prisms. Prisms are going to be the harder one compared to cylinders. I'm going to draw another one. A rectangle. What's up, Liam? What? No, there is another scene cylinder. What's up, Gian?
Saying Vincent's so smart.
Oh,
Vincent is so smart.
Draw a rectangular prism. Rectangular prism. And a cylinder.
Wait, draw slow.
Okay. I will slow down. Okay, we're talking about volume. We get our volume from what our bases are. We need to know our bases in both problems. What is the base of this prism currently?
The rectangle. Square.
Is okay. I have technically a lot of different shapes right here. It should be this bottom one though, right? This bottom is our base. I think, yeah, in this case it's kind of a square. This is the base down below. The volume formula for any prism is base, big B, times height. Big B is the area of the base. Prime. So how do I get the area of the shape down below? Base times height. Because it's what type of shape?
Rectangle.
So square or a rectangle. To get big B, so the area down below, we do length times width. So this is length, this is width, this is our height. Renato gave us the one for triangles. Rogue, what was it? Yeah, base times height. So it's a little b. So little b would be right over here. And our height would be our altitude drawn down. This is our h. I drew it really, really tiny. Do you want me to draw it bigger? That's our area formula for the base of a rectangular, triangular prism. Say it. Because this is a square or a rectangle. This is the formula. If I had a triangle, this would be the formula. We have another 40 shape. Well, not 40. Four-sided. Klein, what shape is that? A rhombus? No, trapezoid. Yep, trapezoid. Trapezoid. And remember the area formula for a trapezoid. Say it again. Yep. So a plus b over 2 times our height. This is, okay, Liam said base 1, base 2. So this is a, this is b. And we need our height here. Height. Liam, did you guys do that this year? No?
Yes.
That should have been in like the first half of the year. It's okay if it's not. But now you have the formula. I'm not going to really focus on trapezoids, but there will be one in your homework. That's the problem. Okay, this is all big B. This is all the big B. It just depends on what your base is for the prism. Sophia, a cylinder is so much easier because a cylinder doesn't change the base. A base is always what shape in a cylinder? Circle, right? Yep. No, you're fine. Volume is still base times height. This is my base. My base has a radius. Rodelia, I think you gave it to me. What is the area of a circle?
Me?
Yeah.
I don't know. R squared. Wait.
Yeah.
Oh.
Pi r squared. So the volume formula becomes pi r squared times height. So you can get the area of the circle, and you want the height, which is from here to here. That is my height. So you want to remember this formula, and sadly for this one, you're going to have to change it a few times. Times h, if we're looking over here. Kevin, you good? What are you trying to get? Ice? Oh. Give him the end of it? You give him the end of it? Okay. Okay, any questions about volume formulas? We're gonna have to change the base when it looks a little different. So when I change, so my base is different. So if it's a triangle, I have to use this formula and plug in for big B.
Even if it's
Only if it is a triangular prism. So if I have a base of a triangle. So if I looked up, that was a triangular prism. This guy's a triangular prism. So I would need to change my equation for that. Okay. Ronaldo is tired and is gonna fall asleep. So I think we all need to get up and get into groups. We're gonna get up and get groups. Our brain break was sucked up by. Okay, we have 2 minutes left for brain break.
I heard brain break.
2 minutes left. We didn't
Yeah,
even start.
the first 3 minutes. Class started late.
Wasn't you?
No.
What do you want to do for brain break, Vincent? No, you get up. Get up, and you won't sit back down. Up, up, up. No, up, bus driver. Sonny, you just said you loved the bus game earlier.
No.
That's the whole point. Okay, up, up, up. I can't tell you that. Okay. Black and red. So red's over there. Around the box. 15 centimeters. Let's do 5 centimeters. And radius. Okay, going to groups is 2.5 centimeters. Okay. Yes, you can, Drew. What's the units?
Centimeters.
Centimeters? Yes. Okay. Do the math. Oh, don't go back and touch none. Okay, why is it? What?
Can I see my group?
See the what?
My group.
Oh yeah. Sevilla, you were in with Prime and Ronaldo. So right here. Yeah, you're over here. Sevilla. Erase, yeah. What? Were you not paying attention? Sophia, where is your name? Sophia, go join 6. That's so weird. Okay.
Okay. It's done. We've done this before.
For what? A cylinder? Yeah, right here. Yep.
Oh, this is really easy.
Okay, find the volume of this one.
Oh, what this?
So wait, we have to find this part first. Sorry. 15 times. This one is base. 15 times 5 is 7.
Okay, that's the volume of the cylinder. I want to know how much volume.
I think it's 70. 75 times 5 is 7. No.
15 times 2 is 30. Times 5 is 60.
Find the volume around the cylinder. What? This is the box. The volume of the box. Then I put something in the box. How much space is left in the box?
So then, base,
So take the box. Take that.
big B,
Subtract the
subtract.
For the base is
Wait, is this telling us that it's 2.5 centimeters already? Yeah.
See this.
Pi times.
Y'all slow.
Oh. Never mind. Oh. And then. Oh. Oh.
62.5.
Where's pi? Oh, got you. Oh.
196. Wait, do we put it to terms of pi still?
No, multiply pi now.
Multiply pi now?
Oh.
What are we rounding to? Oh.
We'll just start with the.
Okay.
Yep.
I got you.
0.46 centimeters. Or cube. Wait, what was the question?
How much space we got?
Oh, I see. So we done?
Oh, this is nice to know. What is this? Ew, oh. Oh, is it sticky? Oh,
It's paper.
I thought it was sticky. I was like, I thought something was sticky on me. Oh.
Severe.
Hey, what just happened, guys? That wasn't even me.
I'm not in there. Ronaldo. Oh, you are in there.
She told me to move it, and she's like, Sylvia, you're okay. And then when she showed me the paper, I was like, what is that?
Shit.
So, like, you played my face? Oh, okay. Is that it? Guys, who drew L in the back? So cute.
We are done.
Really? Oh, this is cute.
I'm pretty sure you got both this one.
Oh, is that what?
Thanks.
This is cute too.
We don't work your fingers.
Guys, when
We
I
should look.
when I type, I do this.
Yeah, finish. I like it. Leave these with the group and pick out what's out. You guys stuff.
Alright. Which one do you guys want to choose?
Oh, let me see.
Make me the shortest
This
one.
nice
Prime.
one.
You can do the one that says prime.
Why the heck?
All right, fine then.
13 neon tetra. Yeah, I don't really want to do that. That's weird.
This neon tetras. What is that?
1 gallon equals.
Oh, that makes sense.
Gallon. Oh, it's a quid. What's a neon tetra?
Oh, it's just.
Oh. So it's like that cylinder-looking tube that animals swim in. Oh, like Finding Dory.
Wait. Why don't you just?
Oh,
Wait, it's asking if I'm going to be.
So 2 gallons, guys.
It's by now. Okay.
So
What? How do you all pick different ones?
because we're different like that.
So go back to your seats. We'll do the garden one together and do the rest of the other.
What is it, Dion? Something,
Like,
something.
we're gonna do them in groups on your own.
Okay.
English or even my
Okay.
first language. Yeah. Yeah, it's fine. Okay. Did you guys all read the problem?
Yeah.
We should probably write it down. This thing unplugged. That's what happened.
Oh no.
No, it's fine. No, it didn't unplug. Why is it in this writing? Love. Okay. Everyone, write down the problem. It's gonna be a second until I can get this back up.
Garden one?
Yep. I'm gonna read it to you. A garden's raised bed is in the shape of a raised square that is 4 feet and 10 inches tall. That's the problem.
Oh, were you giving us?
Should I s- No. I have to get it back up because I can't write. So it's gonna be a minute.
You can see me drowning.
Okay. A raised garden bed is in the shape of a raised square that is 4 feet and 10 inches tall. Estimate how many 10 by 18 by 5 soil bags is needed to fill the raised bed. Okay. A raised garden bed is in the shape of a raised square that is 4 feet and 10 inches tall.
Can we just convert the feet into inches, Miss Sweet?
What?
Can we
Yes. Convert everything into inches.
I don't get the 10. This is one.
Yeah. Well, we're gonna do it. So we have a square. Is a raised square. 4 feet by 4 feet. And we raise it up how much?
How's it 4 by 4?
Is a 4 foot and 10 inch tall raised square garden. It is now 10 inches tall. Sure.
Oh my god. Wait.
Yeah.
No.
No. 4 feet. 4 feet. No. No, homework is great. This is 4 by 4 by 10. This is our garden. You estimate how many 10 by 18 by 5 soil bags is needed with my phone. This bag is in inches, by the way. Inches. Is needed to fill the raised bed. We don't have to start. I want to find the volume needed for inside the bed, the garden bed. So I need to find the volume inside. What shape is this? It's a 3D shape. Rectangular prism. Rectangular prism. So I have volume equals length times width times height. Because this is my base. So this is my big B. Big B is length times width. Now, Rogue, I can't just multiply these all together. Why can't I just multiply 4 times 4 times 10? Yep, I have to convert. So, 4 feet. How many inches is that? 48. Yep, so it's 1 foot has 12 inches. So now I have 48 by 48 by what? By 10. Boom. Then we have the volume of a raised bed. What would it be, Keegan? Everyone grab a calculator. See what you get. Should have a calculator.
48 times 48.
48 times 48 times 10. So length times width times height. What is my units?
Meter. Centimeters.
Inches cubed. Because we changed everything to inches. Inches cubed. Okay. We're not done. That's just the volume of the bed. I want to know how many soil bags we need to fill the raised bed. I like the idea of dividing it, but I have to divide it by something we haven't found yet. I need to find the volume of something else. What else do I need to find the volume of? Yeah. So I need to find the soil bags, which is 10 by 18 times 5. So it's also a rectangular prism. What's up, Anna? Volume equals length times width times height. Finish it for homework. Find how many bags needed. Yep, that's it. Just one problem. Wait. No, I forgot. You had the other homework.
We're so close.
Okay, you don't have to finish this one for homework, but you have to finish the other one. You don't have to do this one. Thank you.
26 or 25.6.
No, it should be. No, you're at 26. The other problem was 8. I had it
I was
memorized.
like, it's not 8.